Today we are going to teach you guys about the central limit theorem. Follow me inside and let's start our lesson.
Hi guys, let's begin with a set of numbers. Here we have 4, 7, 7, 8, 14. The mean of a set of numbers or our population is 8 and our standard deviation is 3.2863. This is our sample space.
Since we're using sample sizes of 2 from our set of numbers, this is our sample space and we have 16 samples of size 2 with replacement. Although our sample space has 16 samples, there are 25 possible outcomes from this set of numbers. And here's a two-way table. Showing the 25 outcomes. Here is another two-way table showing the probabilities of all these 25 outcomes. And every single one of them is 1 over 25. Even though there are some repeating samples, all of them have a probability of 1 over 25.
Calculated the sample mean of all these samples of size 2. Here is the standard deviation of our samples.
We calculated the mean of all our sample means and we got 8. This is correct because it coincides with the central limit theorem, because the mean of our original population, of our original set of numbers, was 8 as well. We also calculated the standard deviation of our sample means and we got 2.3238. We put a check mark down there because this coincides as well with the central limit theorem. If we take the standard deviation of our original population, which was our set of numbers, and we divide it by the square root of the sample size, and our sample size in this case is 2, we get the same exact number for both standard deviations. Here is our sample means distribution graph. As you can tell, it's approximately normal. So let's talk about what the central limit theorem states. So the central limit states that if we begin with a population and we take many different simple random samples from that population, just like we did, we took a set of numbers and we took many simple random samples of size 2 with replacement, and we take the sample means of all those, and if we calculate the mean of the sample means and the standard deviation of the sample means, we should have the same mean of the sample means that we did in the population, and we should have a standard deviation divided by the square root of n as our standard deviation of the new samples. This works with the central limit theorem because the central limit theorem is trying to prove that if we take many samples from one population, we can have a approximately normal distribution. So even if we start with a population that doesn't have a normal distribution, if we take many different simple random samples from it, we can actually assume that we will have an approximately normal distribution. The more you increase your sample size, the more approximately normal your resulting distribution will be. If we were to increase our sample size, in this case we had sample sizes of 2, if we were to increase the sample size, we could show you and we could expect to have a sampling distribution that is more normal.
As you can see, the central limit theorem is very useful. We could take a distribution of numbers that aren't approximately normal and take simple random samples of large sample sizes for us to assume that the final sample distribution is approximately normal.
Thank you for watching our project, and we hope you learned something from this lesson.
About the central limit theorem.
Central limit theorem is super cool.
Alright. We love you, Mrs. Afrin.
Thanks for being a great teacher this year.
Alright, yeah.